Okay, so the topic for today is which database to choose in system design interviews. And I'm sure this is going to be a very interesting discussion and a very essential one as well, because this is one of the core discussion point during the interviews. Let's set up some ground rules first. So please put questions in question box only. Do not use the comment box. Then please afford similar questions instead of asking a redundant question. It saves time for all of us. And I will pause at the critical moments during the class and I will go through the questions from the top, which have the highest votes. I won't be checking the comment box and I won't be checking the raised hands. If a question is not clear to me, I will request that person to speak. Yeah, and we can have raised hands at the end if time permits. Please mute yourself. And yeah, one important advice that I would like to give is that please make use of IK mocks. They are your best friends. It was the game changer for me. And a disclaimer, I do not claim to be either a know-it-all guy or always correct guy. I'm open to feedback and corrections. Okay, so let's get started. The agenda for today is that first we will go through the CAP theorem. It will be revisited. So I'm assuming that everyone has gone through the fundamental classes by Omkar, in which Omkar has beautifully covered the concepts of CAP theorem. I'll be just reiterating on small points and covering some critical aspects of CAP theorem. Then we will see an approach that how do we decide a database in interview. There will be high level introductions to the whatever data options we have available. Then we will have some case study on Netflix. We will have some quiz time and some advice from my side again. Okay, so let's get started. Okay, so for CAP theorem, the first important part is partition tolerance. Now, what is partition tolerance? So as we can see in this diagram here, so let's say these are three database instances. Now these two servers, they are in sync with each other because the network connection is there. But this one goes out of sync because the network connection is down here. Right? So this is a partition. Now there are two partitions here. This is partition one and this becomes partition two. So this is partition. Now a distributed system should have tolerance for these kind of partitions. A distributed system should continue to work even after this partition happens. We all know that networks are highly unreliable. There are a lot of weird cases. There was a weird case when an actual white shark ate the fiber optics inside the ocean, and there was a huge network problem in the coastal areas of Asia. So they can go down for any kind of weird reasons. So that's why a distributed system must have partition tolerance. Now, this means that in CAP theorem, we need to have partition tolerance. So whenever there is a network partition, now we can choose only C, that is consistency, or we can choose only A, availability. So only one of consistency or availability. Moving forward. Now let's see the C part of CAP theorem, consistency. Now the consistency in CAP theorem is completely different than the consistency in ACID. I hope everybody knows about the ACID, which is the property of relational databases. Yeah. I've seen that this kind of confusion crops up many times. So let's see what is consistency in acid property first, and then we will see what is consistency in CAP theorem. So it says data is in a consistent state when a transaction starts. Data is in a consistent state when a transaction starts and when it ends. So let's say this is the state of the system. Now the database transaction happens here. And even after that, the state of the system remains consistent. Right? So this is consistency in acid property. Let me explain it. Let's say this is the before transaction part. Here we have an account one whose balance is 5,000, and there is account two whose balance is 1,000. And if we, let's say these are some kind of related accounts, so the total balance is 6,000. Now we start a transaction where we have to transfer 1,000 from account one to account two. So how do we do it in RDBMS world? We begin a transaction, then we update the balance for account one, and we set it to 4,000 because we are removing 1,000 from it, and we set the account balance for account two as 2,000 because it has got 1,000, and then we commit transaction. And after this, this should be after. So after transaction, the account one balance is 4,000 and account two is 2,000. So total is 6,000. So still the system is in a consistent state. It has not happened that the account one balance is still 5,000 and account two balance has become 2,000. If that would have happened, then that system wouldn't have been in a consistent state. Right? So this is consistency in acid. Now let's see consistency in CAP theorem. So it says every read request receives the most recent write or an error. So output should be most recent write or an error. So either I see the most recent updated data or I get an error. I don't see a stale data. This is consistency in CAP theorem. Right? Let's understand the diagram from the previous slide again, now in the light of CAP theorem. If any account balance for account one, ACC1 is fetched before or during transaction, that means here or here. before and during transaction, response is 5,000 because till this point, account one balance is 5,000. And when the transaction has been committed, and if anybody wants to fetch the account balance, then it should come as 4,000. So it should not happen. Let's say this balance has been updated on DB1 server. Now say there are some replicas for this database, DB2, DB3. Now if my read request goes to, let's say, DB3, and I want to read the account balance for this ACC1 person, if I get a response 5,000 from this, then I'm getting stale data. Then this system is not consistent. So ideally, what should happen is that this person, if this person does not have stale data, does not have fresh data, then I should get an error here. And if the request goes to the updated servers, then I should get 5,000 balance. Yeah, so consistency is clear now. And even if you have some doubts at this point, I would request you to hold on, because I will be covering some more slides where we will see some actual cases and things will become even more clear. And I will stop at that moment and then I'll take more questions. Yeah, so that if anyone has doubts, they do not have clarity, we will discuss those things again. Availability. So this is the A of CAP theorem. Every read-write request on a known non-failing node. Every read-write request on a non-failing node must receive a non-error response. Right? So what we saw in consistency said that give me the most updated data or give me error. Availability is saying failure is not an option. So that means I don't want to see an error. So if the read request comes to the system, don't give me an error, always give me some data. So that data could be fresh, that means the updated data, or it could be the stale data. So this is availability. Now again, one clarification, which I have seen that most of the times confusion is, this availability is not the same as the 2 nines and 3 nines and 4 nines of availability that we talk about in the context of fault tolerance. This availability is different. It simply means that in case of partition, so let's say this is my DB1, this is my DB2, this is my DB3, and there is a network partition. These guys are in sync. Right? So if the request goes to any of the server, that request should be served. Even it is possible that this person, because there is a network partition, this person is, this database server is giving stale data. Now let's say if there is a server DB4 server also, and this server is out of service due to some reason. So if the read request goes to this person, then obviously no response would be there. That's why we said that non-failing node must give a non-error response.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, Our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today